On the third page, we have probability problems. The definition of probability is the number of ways you can obtain success divided by the total possible things that could happen. In this case, there are 1,000 integers, so that'll be our denominator. And to find the probability of 0, 0, 0, you simply have 1 divided by 1,000, one way to choose 0, 0, 0. Less than 999, well, there are 999 numbers less than 999 and only one that is not less than, so it's 999 over 1,000. And to find a value that's actually greater than 999, that would be impossible since the numbers are all between 0 and 999. So the probability is 0. There is no chance of obtaining a number that's greater than 999. Notice to select an ace, there are 4 aces in a deck of cards, so it's 452. 13 clubs, 13 out of 52. And then there are 4 jacks, 4 queens, and 4 kings for a total of 12 out of 52. Now in problem 7, you're selecting things from a hat. Notice there's only one ID number that is your ID number, so it's 1 divided by 4. Notice if you have 4 students selecting without replacement, when you remove one, the probability the next person selects one is different, and therefore you have this conditional probability along with the multiplication rule. For part C, you simply multiply 1/4 for each person because the probability doesn't change since you are replacing the numbers. For D, this problem would actually be more difficult than something we'll look at for this test because you'd have to look at all the different ways you could arrange those selected cards. But if you just did them in a particular order, it would be 1 out of 52 times 1 out of 51 and so on for 1 over 311,875,200. The probability that you get something or something else is given by the formula of the probability of having the first plus the probability of having the second minus the probability that the two occur at the same time. If you want the probability of getting 2 occurring at the same time, you simply solve for P and the probability of A and B, and you notice you get a very similar formula. Now in problem 8, you're looking for sample space. And sample space simply means all the possible events that could happen. Notice I can list it in 2 different ways. One is listing the pairs, and another way is actually in a multiplication table-like form, listing all the sums. It's very easy in the second form to count the number of 7s that could occur, so the probability of rolling a 7 is 6 over 36. And the probability of getting a number less than 10 would be the complement of getting a number 10 or larger. So I take the 1 minus the probability of getting something greater than or equal to 10, and that gives me the probability of getting something less than 10, which is 30 over 6, which equals 5/6.